Data preparation plays a vital role in maximizing the performance of language models by optimizing datasets for various tasks. Let's explore the essential key functions in data preparation for LLMs that facilitate this process. Data object. This feature allows you to input datasets for various tasks, making it easy to work with different data types. Example: you can input different types of texts, such as customer reviews, news, articles, or social media posts. Data augmentation. You can combine or augment multiple datasets, enriching your data with diverse information regardless of the task. Example: if you have a dataset or book reviews, you can combine it with another dataset containing movie reviews to have more diverse opinions. Text cleaning. Using various cleaning methods, this function ensures text data is clean and ready for all tasks. Example: removing special characters or emojis from tweets to ensure clean text. Profanity check. Identify and remove texts containing profanity to maintain language standards, particularly useful for question and answer tasks, tuning, conversations, and pre-training. Example: filtering out text containing inappropriate words to maintain a respectful environment. Text quality check. Filter out low-quality texts to ensure the performance of tasks like question and answer, tuning, conversations, and pre-training. Example: filtering out poorly written text or text with spelling mistakes. Length checker. Filter the dataset based on user-defined length parameters to suit task requirements. Example: filtering out tweets that are too short, less than 10 characters, or too long, more than 280 characters. Valid question. For question and answer tasks, this function ensures that each row in the question column actually contains a question. For example, apples are green is not a question and would be filtered from the dataset. Pad sequence. Consistently pad sequences based on a maximum length parameter for all tasks. Example: adding zeros at the end of short sentences to make them all the same length. Truncate sequence by score. Truncate sequences based on a score and maximum length parameter, essential for all tasks. Example: removing sentences from a text if their sentiment score is below a certain threshold. Compression ratio filter. Designed for text summarization tasks, this feature filters data by comparing the compression ratio of summaries. For example, filtering out summaries of articles that are too short or too long compared to the original content. Boundary marking. For text summarization tasks, this function adds start and end tokens to the summary text. Example: adding start and end tokens to the beginning and end of the summary to indicate its boundaries. Sensitive info checker. Essential for the process of fine-tuning instructions, this function plays a crucial role in detecting and excluding sensitive data, such as the removal of client credit card details, as an illustration. RLHF protection. Facilitate reinforcement learning from human feedback for all tasks with appropriate dataset appending. Example: appending additional feedback data for the model to learn from during reinforcement learning. Language understanding. Filter text based on language using user inputs on a given threshold, beneficial for all tasks. Example: filtering out text written in languages other than English. Data deduplication. Calculate text similarity and remove duplicates across all tasks. Example: removing duplicate customer feedback comments to avoid redundancy. Toxicity detection. Calculate toxicity scores and filter texts to maintain a respectful environment. Example: identifying and removing offensive comments from a dataset. Output. Convert the transformed dataset to an output object, such as JSON, usable and exportable across all tasks. Example, saving the cleaned and prepared dataset in a format that can be easily used by the language model, such as a JSON file. Utilizing a tool with these key capabilities empowers you to confidently curate datasets for diverse tasks, enhancing the performance of your language models while guaranteeing data quality and pertinence. However, if you're an experienced data scientist, you might have the following questions. Andrea, a substantial portion of my dataset is unstructured, such as PDF files, and must be converted into clean Q&A type data for downstream language models tasks like fine-tuning before even starting to use these key capabilities. What if I intend to meticulously choose, structure, and enhance my data's quality and relevance prior to leveraging these crucial functionalities? What you're referring to is the necessity for effective data curation techniques without the need for coding. This involves cleaning and structuring unstructured textual data into a question and answer format. In this context, preprocessing means cleaning and aligning text data by eliminating irrelevant content, rectifying errors, and ensuring consistent formatting. On the contrary, structuring implies organizing content with a Q&A framework. In this context, each fragment of data is transformed into a question-answer combination. This procedure involves extracting vital details from the text and creating questions that align with the given answer. Undertaking this manually isn't advisable, as it consumes a significant amount of time that could be more productively allocated to other meaningful endeavors. Imagine you have a comprehensive article discussing the benefits of exercise. Within this document, you'd identify the crucial points that are about different types of exercises, their effects on health, and potential challenges. To curate this data for Q&A language model tasks, you'd perform the following. Extract key information. Pick out the significant facts from the article, such as types of exercises, health impacts, and challenges. Create Q&A pairs. Transform the key points into questions and provide the corresponding answers based on the article's content. For example, question: what are the different types of exercises discussed in the article? Answer: the article covers aerobic strength training and flexibility exercises. Question: how does exercise influence overall health? Answer: engaging in regular exercise has been shown to improve cardiovascular health, boost mood, and enhance physical fitness. Question: what challenges might people face when starting an exercise routine? Answer: some challenges include lack of motivation, time constraints, and the need for proper guidance. This transformation aligns the article's insights with the Q&A format. Consequently, when using this curated data for tasks like fine-tuning language models, the models learn to generate relevant responses to questions based on the article's content. This approach capitalizes on the established Q&A format's effectiveness in various language processing applications. A tool that supports such data transformation can be immensely valuable for data scientists, as it automates the process of structuring and refining data to fit the Q&A format. This facilitates downstream tasks like fine-tuning, making the data more available and relevant for training and enhancing language models.